In August of 1977, a radio telescope in Ohio picked up something impossible. A sharp, narrowband radio signal, one that lasted just 72 seconds, beamed from the constellation Sagittarius. It wasn't random static. It wasn't interference. It was clean, structured, and incredibly strong. Astronomer Jerry Amon circled it on the printout and scribbled one word in red ink: wow. To this day, the wow signal remains one of astronomy's most haunting mysteries. No comet, planet, or satellite can explain it. It came from deep space, and it never repeated. For decades, scientists have searched for another like it, but the universe stayed silent, or perhaps just quiet enough for us to miss the whisper between the stars. When pulsars were first discovered in 1967, the scientists who detected them were baffled. They recorded rhythmic bursts of radio waves, so precise that some wondered, could they be messages from intelligent life? They even labeled the first one LGM1, short for Little Green Men. Of course, we now know pulsars are rapidly spinning neutron stars, the remnants of massive stars that exploded long ago. Yet, even today, their perfection is staggering. Each pulse arrives with the timing of a cosmic metronome, to the millisecond. If nature can create a beacon that's perfect, what else might be out there, broadcasting patterns too subtle for our instruments to decode? Back in 2007, a graduate student, just sort of sifting through telescope data, stumbled across a sudden spike of radio energy that lasted less than 5 milliseconds. It came from billions of light years away, a flash brighter than an entire galaxy. This was the first fast radio burst, or FRB, and honestly, it was an astronomical event so intense that it just defied explanation. Some folks think FRBs come from colliding neutron stars. Others reckon it's black holes or maybe magnetars. But here's the strange truth. A few FRBs actually seem to repeat irregularly, unpredictably, almost as if something or someone is transmitting them on purpose. Each signal arrives distorted by the intergalactic medium, stretched, scattered, but still intact. They're like postcards from the farthest reaches of existence. For every clean signal we manage to detect, there are billions more just hidden in the static. Radio telescopes record these endless data streams, noise coming from quasars, stars, galaxies, and, well, who knows what else. These days, artificial intelligence is scanning that whole cosmic ocean, looking for non-random patterns, signals that might show logic, repetition, or some kind of intelligent structure. Some researchers have even found faint modulations buried deep in the radio background data, sequences that appear deliberate but just defy classification. So, could they be natural phenomena we don't yet understand? Or are they artifacts of civilizations that communicate in ways totally beyond our comprehension, maybe using energy fields or even physics itself as their language? If an alien intelligence were, let's say, millions of years more advanced than us, would we even recognize their signal if it ever reached our world? Every single day, telescopes like FAST in China and the Allen Array over in California sweep the sky, searching for a repeat of that first wow. We still haven't heard it again. But you know, the silence might not mean emptiness. Maybe the cosmos is actually alive with conversation, and we're just learning how to listen properly. It could be that our instruments are still too young, or maybe the signals are out there just encoded in forms we've never even thought to measure. Or just maybe, the universe itself is the message, a vast, conscious system, speaking in light and gravity, just waiting for us to understand. Until then, humanity continues to listen, ears pressed against the infinite, waiting for the next whisper from the dark. If the unknown fascinates you, if you want to keep exploring the mysteries hidden in the fabric of space and time, go ahead and subscribe, like, and comment below what you think these deep space signals might really be. Every interaction helps us reach more curious minds who dare to ask the same question: are we alone? Have you ever looked up at the night sky and wondered what's out there? The universe has been sending us messages, not in words, but in waves, pulses, and mysterious signals that travel across the cosmic void. These strange signals are whispers from distant galaxies, hinting at the most powerful and enigmatic phenomena in the cosmos. Decoding these cosmic whispers is one of science's grandest adventures, a detective story on a universal scale. Each new signal brings us closer to understanding the universe's fundamental workings. So let's venture into the heart of the cosmic static and explore the most bizarre and fascinating signals ever detected. Let's get started. Our story begins with a wow, literally. August 15th, 1977. Astronomer Jerry Eman is at Ohio State's Big Ear radio telescope searching for signs of extraterrestrial intelligence. For weeks, it's been the same cosmic hum. Then, for 72 seconds, something extraordinary happens, a powerful, narrow-band radio signal, unlike anything seen before. It's a spike in the data, focused, strong, and not matching any known natural or human-made source. Reviewing the printout, Eamon circles the sequence 6EQUJ5 and writes "wow" in the margin. The signal's frequency is close to the hydrogen line, a frequency scientists theorize would be ideal for interstellar communication. The wow signal was a watershed moment, the first signal that matched what we might expect from an intentional extraterrestrial transmission. It was structured, powerful, and came from a direction with no known planets or celestial bodies. Astronomers scrambled to listen again, but the signal never returned. It was a one-time event, a cosmic ghost. Was it a secret satellite, a new natural phenomenon, or a message from ET? No one knows. The wow signal remains one of astronomy's greatest unsolved mysteries. Its transient nature is maddening. If it were natural, it should repeat. If it were a message, why only once? Despite no follow-up, the wow signal ignited imaginations and galvanized science. It proved the search for extraterrestrial intelligence is filled with real, tangible mysteries. The wow signal stands as a monument to the unknown, a cosmic cliffhanger that set the stage for a new era of listening to the stars. Before the wow signal, another mystery was unfolding. In 1967, Jocelyn Bell Burnell, a graduate student in England, noticed something odd in radio telescope data, a series of perfectly regular pulses. These pulses arrived every 1.337 seconds, so precise you could set your watch by them. At first, the team suspected interference, but the signal moved with the stars. It was coming from deep space. The regularity was so perfect, they jokingly called it LGM-1, Little Green Men. But then, more signals appeared from different parts of the sky, each with its own unique pulse period. The alien hypothesis faded. The real explanation was even stranger. These were rapidly spinning neutron stars, the collapsed cores of massive stars, now called pulsars. Imagine an object with more mass than the Sun, crushed into a sphere just 20 kilometers across, spinning hundreds of times per second. As it spins, it emits beams of radiation from its magnetic poles. If one sweeps past Earth, we see a pulse, a cosmic lighthouse. The discovery of pulsars confirmed neutron stars' existence and opened a new field of physics. These cosmic heartbeats weren't alien messages, but signals from one of the universe's most extreme states of matter. Today, thousands of pulsars are catalogued. Their precise timing helps us test Einstein's theories, search for gravitational waves, and even map our galaxy. What began as a bit of scruff on a chart became a fundamental tool for understanding the cosmos. In 2007, the universe surprised us again. Duncan Lorimer and his student David Narkovich were searching old data from Australia's Parkes radio telescope for pulsars. Instead, they found a single brilliant flash of radio waves, lasting less than 5 milliseconds, but releasing as much energy as the sun emits in days. This was the Lorimer burst, the first fast radio burst, or FRB. Its dispersion measure suggested it came from billions of light-years away, far outside our galaxy. At first, scientists were skeptical. Was it a glitch, lightning, or even a microwave oven? But the signal's characteristics pointed to a real astrophysical event. For years, the Lorimer burst stood alone. Then, in 2012, more FRBs were detected. Suddenly, the sky was full of them, thousands per day, all over the sky. The discovery launched a new field of astronomy. The mystery shifted from, are they real, to, what are they? Leading theories involve colliding neutron stars, collapsing massive stars, or magnetars, neutron stars with immense magnetic fields. The search for the source of these cosmic flashes continues as we try to understand what could generate such immense energy in milliseconds. Beyond bursts and pulses, there's another signal, everywhere, all the time, the cosmic microwave background, or CMB. This is the afterglow of the Big Bang, a baby picture of the universe at 380,000 years old. Discovered by accident in 1965 by Penzias and Wilson, the CMB is a faint, persistent hum, remnant heat from creation itself. At first it seemed uniform, but sensitive instruments revealed tiny temperature variations, fluctuations that are the seeds of all cosmic structure. These minuscule differences became the blueprint for galaxies, stars, and clusters. By studying the CMB's patterns, cosmologists decode the universe's age, expansion rate, and composition: 5% normal matter, 27% dark matter, 68% dark energy. Scientists now search for even subtler patterns like B-mode polarization, a twisted signature that could confirm cosmic inflation, the universe's rapid expansion after the Big Bang. Finding this would be like discovering the first word in the universe's instruction manual. The search is difficult, the signal is faint, buried in noise, but the potential payoff is immense. The CMB is the most information-rich signal we've ever received, a message from the past, carrying the secrets of our cosmic origin. From the WOW signal to pulsars, FRBs, and the CMB, our journey shows the universe is anything but silent. We're in a golden age of exploration, building bigger, more sensitive telescopes like FAST and the Square Kilometre Array. These instruments will detect fainter, more distant signals than ever before. Maybe we'll even solve the WOW signal mystery. The search for extraterrestrial intelligence continues, with projects like Breakthrough Listen scanning millions of stars for technosignatures, signals that could only come from advanced technology. But listening to the universe is about more than finding aliens or exotic stars. It's about our drive to explore and understand. Every new signal expands our perspective and reminds us how much we still have to learn. The universe is a book written in a language we're just beginning to decipher. We point our instruments at the darkness, listening for whispers of colliding black holes, ticking cosmic clocks, and echoes of creation. And so, we continue to listen. Because out there, the universe is talking, and the greatest adventure is learning how to hear what it has to say. We've journeyed from the WOW signal to the echo of the Big Bang, uncovering clues in the universe's grand detective story. But the story is far from over. The cosmos is still full of mysteries, and these signals pose some of the biggest questions of all. What do you think these signals mean? Are we on the verge of discovering new physics, or just hearing echoes of extreme cosmic events? Share your thoughts and wildest ideas in the comments below. Thank you for joining me on this exploration of the universe's most mysterious broadcasts. If you enjoyed this journey, hit subscribe and ring the bell. We have many more mysteries to explore together. Until next time, keep looking up and keep listening.